Ampapa. Welcome back to the bench. We have an Ampapa to review for you today. What is an Ampapa? Well, I'm not sure. I think it's a little Class D amplifier sent in from Douk Audio for me to review. And that's what I'll do here. Let's pop open this Ampapa. Nice presentation here with this Ampapa. Let's see what we got here. We got a little card here. Amplifying all passion. So it's a model D1. Okay. Well, I gotta unpack it further. In the package we get the amplifier itself. So it just has a control knob and a screen on the front and a top window here. You can see inside. I wonder if it has the LEDs inside. On the back of the unit, oh, here's the side. It has Ampapa vents. Ooh, classy stuff here. What do we have on the back? We have a Bluetoothy antenna thing. HPF, that must be a high-pass filter. So if you want to use a separate sub, you can cut bass from getting to your main speakers. That's always a good idea. And what do we have here? We have RCA jacks. And what are these? A 1/4 inch. I'm going to guess that they're balanced jacks. 1/4 inch balanced jacks. I've not seen that before. We have the pre-out and a 12-volt trigger, so you can, control other devices with that. Or does that allow other devices to control the amp? I'm going to have to RTFM that one. Of course, your speakers and your power, 24 to 48 volts. We also get a remote control, a Bluetooth antenna, power cords, and a gallium nitride adapter. Holy switching speed. Okay, well, let's power this thing up, see what it does. And I don't really get into all, looking at all the functions. I'm more of a performance test type guy. We'll hook this up to my audio analyzer and see how it performs. Okay, it's all hooked up. Actually, I've been listening to it for a while. You can see there, it's got the lights down the side, and you can set the color. Lights up the logo on the side, which is actually a vent. So that's pretty neat. Has the meter display here. It's actually pretty easy to use. You just push the button and you can select the input. Keep it on RCA. If I go back in here, I can go to settings, and there's different styles, different meters. So you can select whatever you want. Kind of like the dual meters here. And of course, just adjusting it without pushing it is the volume. So yeah, very easy to use. I don't even have to look at the menu. Sitting idle, though, it's pretty warm. I mean, it's not hot, but it does get pretty warm. So imagine it could get pretty hot playing it at higher levels. Very quiet amp. I have the volume control turned all the way up, and there's just nothing. There's no hiss. I mean, if you stick your ear in it, you can hear the faintest hiss, but yeah, it's a very quiet amp. That's good. giving this thing a listening test for a while. I don't really hear any issues with it. Sounds fine to me. Like I say, low noise. But now I have it hooked up to the load resistors and the quantisylum. And that's more what this video is about, is to take some measurements and see how it performs. Let's get into it. Okay, beginning with my kickoff test, which I tested 1 watt into 8 ohms, 1 kilohertz. Just want to see how it performs. And that is extremely good. 0.00169. That is an excellent performance there. The gain is around 26 dB, as you can see here. I don't see really any non-harmonic related spikes that would be an issue. Everything's pretty low, down almost below minus 100 dB. Just a wee bit of 60 hertz line frequency in, its harmonics getting in. Still nothing to be really concerned about. Frequency response. Wow, we get this peak. You know, it goes maybe a little over 3 dB positive here at the higher end. You know, this is out of range of hearing. This is 20 kilohertz, and we're about 1 dB high. So it's nothing serious, but I think it's just the coil design. It might be designed for 4 ohms. When I switch to 4 ohms, let's see if it drops. But anyhow, at 20 hertz, this thing is completely flat. Even at 10 hertz, it's like a fraction of a dB down. It's like a tenth of a dB. Really excellent performance, except at the high end. So let me switch it to 4 ohms and see what it looks like. Well, with 4 ohms, pretty much what I expected. It's just the design of the output filters. The amp was designed to be used more with 4 ohm loads. You can see at 20 kilohertz, it's a fraction of a dB high. Slight variance in channels. I'm sure it's the tolerance of the filter components. Very slight difference here in channels. Nothing to be worried about. But, you know, it's still pretty flat here on the low end. You know, this is hi-fi performance, really. It's pretty good. Tone control action. The bass and treble controls are turned all the way up. You have a plus 10 boost on bass and treble, according to the on-screen display there. And we're going a little bit above that. We're going to 11, and this is pretty close here. It kind of thickens. I think there might be switch mode stuff showing up, and you can see relative to 1 kilohertz at 0. Yeah, this is good tone control action. It's not harming the mid frequencies here. It's mainly boosting the area below and above. So let's look at the tone control cut. Okay, so now with the tone control set all the way down to minus 10 dB on bass and treble, you can see we're about 11 dB down in the bass region here. And the treble, you don't quite get there. You know, we're about 8 point something, minus 8 point something. And it rolls off here because of the output filter. But yeah, normally this should go down to here. Not that it's going to make a big difference to what you hear, but yeah, it's not quite perfect on the cut position, but I would say overall the tone control action is pretty good. Especially when you have them set flat, there's really zero effect to the signal because it's pretty flat. Okay, folks, here is power versus distortion, where the stuff gets interesting. The red line is 4 ohms. 8 ohms is the blue line, of course. And you can see the distortion, either 8 or 4 is pretty close. In fact, at some points 4 is slightly more, and at some points 8 is slightly more. So yeah, Pretty interesting performance there. Pretty load invariant as far as distortion goes. But anyhow, you can see here at 1 watt and below, very low distortion like we saw in the kickoff test. But as power climbs, the distortion on this thing really kicks up. And we're going above the 0.1 line at around 30 watts. So we're getting out of what I call hi-fi territory. So yeah, not looking too good there. But in your normal listening range, it's going to be down in this area where it is excellent. And you can see around 100 watts, whether 8 or 4 ohms, it's kneeing up into clipping. And we hit the 1% line at 8 ohms. It looks like around 110 watts. At 4 ohms, it looks like it's 135-ish, I'd guess. They don't have hash marks on this thing. It's kind of hard to tell. Plus, it's log, so it's not linear. So yeah, around 135 watts. I mean, that's a lot of power for a home listening amp. But yeah, it'd be nice like with the linear amps where the distortion's more flat, maybe just a little bit of curve. But this thing really climbs up in this distortion as the power goes up. I did watch the power supply, make sure it didn't cut out on me. I would expect more power at 4 ohms. You know, maybe that supply is regulating down when it, instead of cutting out, maybe it starts to lower the voltage a bit and limits our power. Because I would expect to see, you know, if we're getting 110 at 8, I'd expect to be getting around 200 at 4. But okay, I'm back at the kickoff screen where I'm running it at 8 ohms, 1 kilohertz at 1 watts. And you know, I was down at 0.002 initially, but now I can only get down to 0.007. I wonder what's going on here. Seems this third harmonic has peaked up. Kind of wondering if that's temperature dependent. When I started it was close to 0.01 and it's been dropping. So what I'm going to do is unplug the amp and let it cool off and plug it back in and see if the distortion has dropped. Okay, so I let the Quantasylum here run and I unplugged the amplifier and let it cool off. Turned it back on and there you go. Temperature, or I should say the distortion, came down to 0.0022 where it was 0.007 before. It was actually 0.009 initially, but as it cooled off from the previous tests, you know, when you're running those power tests. So I guess that's a good argument for letting things come up to temperature, or at least moderate before testing. But you can see that third harmonic is lower. I think it was up here before. And the highest peak is the one that takes precedence, the way the math works. Okay, so now we're looking at the 8 ohm frequency versus distortion. I did 2 measurements this time. I did at 1 watt and 50 watts. At 1 watt, it starts out pretty good, dipping below 0.01, and we get the real low values around 1K. And it starts a steady incline, going above 0.1% at 9 kilohertz, and finally ending around probably about 0.4% at 20 kilohertz. Now, I'm not a stellar performer, but I don't think distortion is really audible at these higher frequencies. At 50 watts, though, you can see we're quite a bit higher, as we saw before at 1 kilohertz. But we're going above 1% at, looks like a 4.5 kilohertz. And we're going 2, 3, 4, between 4 and 5% at 20 kilohertz. So yeah, not a real good spec sheet performance, I would say. A lot more distortion at the higher power. Same deal, but now with 4 ohm loads, 1 watt and 50 watt. So I'm not going to say much because it's quite similar. It's just that with the 50 watt line here, we're getting up in distortion even quicker than with 8 ohms. Now in previous tests, I didn't do a higher power measurement with these Class D amps, but I'm sure you would have seen something similar. Kind of disappointing though that at higher powers, well before clipping, we're starting to see quite a bit higher distortion when we're getting above 1K here. Well, this amplifier has been sitting idle for an hour now. No signal coming out of it. And let's see if I can look at those coils, man. Those things are running at around 155 degrees Fahrenheit. Let's see, the rest of it's not that hot, but those coils are pretty hot. See, the power supply brick there is not very hot at all, 84 degrees. Yeah, that's kind of my complaint. Yeah, I can't really hold my finger on that. Sitting idle. I don't know why they have to run these things at such high voltage. 48 volts. It kind of stresses things. I'm going to run this thing at 36 volts and see how it does at idle. I mean, the case it's not super hot, but it is quite warm for a Class D amp sitting here just idle. Okay, I hooked up the amp to my supply. To get 48 volts, I have to series the 2 channels together. So that's 24 per channel. And we're drawing 190 milliamps. And that is a little over 9 watts sitting idle. That does seem kind of excessive just for a Class D sitting idle. It's going to generate quite a bit of warmth. So curious how that'll drop if I run it at 36 volts. Okay, so now we're at 36 volts. The current didn't drop much, but that comes out to about 6.5 watts. So it's somewhat less. Amp will run a little bit cooler, and if you run it at say 32 volts, it'll be even less power dissipated, so be even cooler still. Okay, I let it set for a while at 36 volts. In both cases I had the cover on here, but to measure it I got to open this. So let's see what it is now. I mean, the case does feel quite a bit cooler, and the coils are now 122F, much better. On 26, depends where I point it. So yeah, it's about 30 degrees cooler. But I do wonder, these coils are, I can kind of see the wire inside, and at 100 watts into 4 ohms, that's about 5 amps of current. So I can actually hold my finger on it now. Anyway, that'll get a lot hotter when you're actually pushing a signal through it. So yeah, at 48 volts with this thing cranked up, I could see these coils getting extremely hot. Teardown time. Let's see what goes on inside. So we have kind of a stacked board arrangement here, and we have a couple boards there for the input section there. There's a Bluetooth board. Power comes in over here. We have this Rubicon main filter cap. Looks like we have 2 switch mode supplies here supplying a positive and negative rail for these op amps. We have a couple pluggable NE5532s. Got some relays here. This chip here, I don't know if you can see the number, Japan Radio Corporation. This is the electronic volume and tone controls. So it takes signals from the microcontroller, which commands it to adjust the volume and tone settings. So that's how that's done. We have, I think that's an NE5532 there. And on the back we have the power amp IC. So yeah, I had to scrape off some of that heat sink compound. You can see it's a 3255 chip there. It has this machined aluminum block which fits over that and acts as a heat spreader, and then the other side of that spreads to this aluminum case. So that's how it dissipates its heat. Nothing really much else going on the bottom of this board. Okay, this is the front panel. You have a little LCD controller chip. I'm not sure if that also contains the microcontroller or those other chips do that. I'll have to look up the numbers. Rotary encoder. So yeah, that's pretty much it as far as the front panel is concerned. So yeah, looks like it's pretty well engineered. I don't see any funny stuff going on. I do kind of question these coils. They get awfully warm, and if they're not undersized or not for the current the amp will have to deal with. But anyway, well, I didn't mention these are the LED. You can see on the bottom side the LEDs shine down onto the board. Okay, enough of that. I'll put this thing back together and come back with my final thoughts. Okay, the Ampapa is back together again with heatsink compound fingerprints everywhere. Let's see what I give it here. Ooh, borderline. It's kind of 3-star hotel. I think it's kind of like a 3.5 out of 5 stars. I do like the implementation with the screen here. It's easy to use. At normal listening levels, distortion is very low. However, yeah, I'm just not crazy about running these things at full voltage, 48 volts. It draws a lot of power. The coils get hot. Imagine if you're really cranking it with 4 ohm speakers, it's really going to get hot. And at higher power levels and higher frequencies, the distortion is not impressive at all. So yeah, I'm going to give it 3.5 stars. Okay, well, appreciate you watching, and we'll catch you on the next one.